Hello and welcome to this episode of Microchips, and on the bench today we have this President AR144. A really good sounding radio. Anyway, before we start, don't forget to like, share, subscribe, comment, all that lot. Have a look at my website, join the Facebook group, and let's get started. Now originally I wasn't going to release this video due to me being not happy with the final outcome of what I was going to do with it. But as we know that this is only a mid-band set, it's a mid-band AM and sideband set, and I wanted high band on it because, you know, 555 would be nice to use this on 555. So I found a conversion in an old CB magazine which meant changing the PLL chip to a different type of PLL chip. Little did I know this was going to cause me a bit of trouble, should we say, and me not being very happy with it. But as you can see, it's on frequency as standard, just the normal mid-band CPT frequencies. So the modification was change this PLL chip to a slightly different number, and we had to do a couple of component modifications. So there's our replacement PLL. Now switching one of the pins on this should switch us into high band, but it's also got a strange side effect where it switches us onto zeros and not the fives. So that means we're going to have to unlock the clarifier to get us down onto the 5, which caused me even more trouble. So we're just soldering in the PLL. Like so. Then we had to join one of the pins together, like so. And then we have to put a switch on the other pins for the high band. So we're just going to test it on the high band, and you can see it puts us on zeros, which isn't really convenient considering we should be on the fives. So how are we going to do this? So the VCO was just a little bit out of lock on the top end, so we'll bring it into lock. Yep, we're getting there. So after a little bit of adjustment, we get that as it should be. Then we need to change the capacitor as well, which is this one. I wouldn't recommend anybody doing this modification because it's a real pain, and I'm sure there's easier ways of doing it these days, but I wanted to try this way. So 22 picofarad in there, probably expands the VCO a little bit. So yeah, typical capacitor for broadband in a VCO. And we've got it this time. Seems to be a lot more stable. So you can see the mid band works fine, but the high band is on the zeros. So we need to fit some form of automatic dropper and allow the clarifier to work as well, which was going to be the start of the problems. So what we're going to do is we're going to put the mid and high band on a switch on the front with these two wires. Connected as such. So that should switch our mid and high in. So we'll do a quick test of that. 965 405. Put the switch in, and yep, it's gone onto high band but dropped onto the zeros, which isn't really ideal. So we need to unlock the clarifier. So we need to find an 8-volt supply, connect one side of the clarifier to it. We need to connect the other side of the clarifier down to negative, which is there. And we need to pull out a diode, which is there. That should give us unlock clarifier on transmit and receive. But the question is, will it move enough? And can we get it to automatically drop us onto the 5s when we switch onto high band? Now, the modification mentions a super slide diode. God knows what one of those is. But we tried various varicaps, an ITT, a BB809, and this is where our problems, well, it wasn't a problem, but it was a bit of an annoyance. So there's an ITT4 I know we're going to put in. So I even tried one of my frequency compensation boards to manually drop the crystal down. That didn't work. As you can see there, I tried that. That didn't work very well. Didn't drop us far enough. So eventually I found if you put an inductor, just a 2.2 microhenry inductor in line with the varicap diode, you could get it to pull a lot further. But I was worried about its stability, and also it had this weird side effect where when you were on high band you had to have the clarifier all over one side, and then when you were on mid band you had to put the clarifier all the way back on the other side, and there wasn't much scope for adjustment. So this was not very good. So just having a look at the 2-tone SSB generator, and everything seems to be okay there. We have a nice waveform, so I've got no reason to suspect that there is any issue with the transmitted signal. And we left it at that. And I wasn't happy with the modification, so that's why I never published the video, because the clarifier had to be all the way to the right for mid band and all the way to the left for high band, and there wasn't much scope for adjustment. It just about reached it. So a long time later I found a project on the internet for a VFO, and I saw somebody had put one in a radio, and I thought, go on, I can make one of those. So luckily I had most of the parts. I just had to get that clock gen board. So we made up a board for it, first out of aero board, and then I had one made, but as you can see there's a few bodges on there for the TX line, and I had to add an extra line on the input, and there were some lines that I didn't need. But this worked surprisingly well. So once I'd used that for a little bit, I had another board made. Hopefully this was going to be the final board. So, by the magic of video editing, there's our blank board, and there's our populated board with the clock gen board, an Arduino, voltage regulators, calibrate button, and outputs for the rotary switch and the OLED. So there it is installed nice and neatly in the radio. We pulled out all the channel change, replaced it for a rotary encoder, and we've got the generator inputting into the 16 meg part of the circuit, which is after the VCO. so we don't need VCO or anything anymore. And this turned out beautifully. Now I know there's going to be some haters for this, because, you know, destroying a nice radio, it can easily be put back to normal. I've still got all the parts. The reason why I didn't do this in an FM set is because it's an absolute pain to modulate this on FM. So it's best to leave it as AM and sideband. Now, I've had some reports on this, and they say it sounds absolutely beautiful. Which isn't to be surprising, really, because the AR144 is a really, really good radio for transmitted audio. But as you can hear, it works beautifully. We've got frequency step. Now, it's not as advanced as some DDS VFOs that are out there. Got no facilities for storing channels or anything like that, but it works, and I was quite impressed with myself being able to get it to work and get it sounding as good as it should do. So whilst I was messing with it, I actually heard a station shouting for contacts, so I thought I'd try and get back to him. Yeah, this is 26 Echo Kilo 168 QSL. Yeah, QSL, my friend, 5 and 9, Manchester, United Kingdom, QSL. QSL, my friend, the name this side is Graham, Golf Romeo, Alpha Hotel, Alpha Mike, 7-3, good DX, my friend. Mike 1 Alpha Tango Mike.
Mike 1 ATM, thank you for the call. You're 5-9. My name is Nick.
Very good morning, afternoon to you, Nick. The name this side is Graham, Golf Romeo, Alpha Hotel, Alpha Mike, located at Manchester, United Kingdom, QSL.
QSL, Graham, thank you for the nice report from Manchester. Wishing you all the best, and have a nice weekend. Bye-bye.
Have a nice weekend. By the way, you're 5 and 9 plus 10, absolutely booming across 7-3, my friend.
Thank you, good luck. QSL, Lima Silva 3, Norway, Denmark.
So that was a really nice contact to get. So I was very happy with that. And this thing seems bang on frequency. And it's a really good usable radio now. So I was very happy with how it turned out after this. I'm very happy with the DDS unit. But anyway, I hope you've enjoyed this video. Like I say, I wasn't going to release it, but after doing this to it, I thought, yeah, go on then, we'll do it. But anyway, thanks for watching. Don't forget to like, share, subscribe, comment, join the Facebook group, join Patreon. Have a look at my website where all my boards are listed. Thanks for watching, and we'll see you in the next episode.